labs like these helped me start my journey into the world of technology. I fell in love with what I learned, and the sheer thrill of seeing the concepts come to life is just like nothing else.
I know. The things you learn while actually involving in the process and doing things for yourself helps you understand, connect the dots and remember so much better.
You know the feeling of making something with your own two hands? The joy and satisfaction it brings you. That is what pushes me forward to do more.
Yeah, it has given me happiness and confidence. Like I found myself, my passion for technology.
I just love colors. Every time I paint, I feel powerful. It is a form of expression for me, almost therapeutic. Here, I have always been encouraged to cultivate and harp out this artistic side of mine. And it's not just art, music, dance, photography, and much more. Here, we get the space to explore all our passions.
College teaches you to see beyond your capabilities, to visualize the unthinkable and catch the unachievable. Life gives you certain opportunities to build your life, but college gives you the platform to live your life. Here, we share our memories, our stories, and our happiness. And it's a roller coaster of emotions. And before you know it, you'll realize that they have turned from friends into family. It isn't always about books, labs, and assignments. Academics are important, but there's definitely more to education than that. It's about finding yourself, about who you really are. It's about carving your own path. In this process of learning and growing, you build your own future. And then by the time it's all over, you realize that you're yet to explore so much more. What seems like the end is just a beginning.
Participants, please mute yourself while in the section, please. Let's give it 5 more minutes for everyone to join, and then we will start the section.
You're beginning with us. When I first walked through the college gate, I never really knew what to expect. There was so much confusion and unfamiliarity. Yet, there was a certain sense of excitement, of experiencing something new, something different. Looking at these new faces, those smiles and chit-chats, I knew my life was gonna change. Learning something new ignites a fire in us. Here, we are encouraged to think out of the box and understand concepts that are taught out of the class. We can sit together, discuss with our friends, and clear our concepts. This way, we can ignite this fire more and more daily.
Labs like these helped me start my journey into the world of technology. I fell in love with what I learned, and the sheer thrill of seeing the concepts come to life is just like nothing else.
I know. The things you learn while actually involving in the process and doing things for yourself helps you understand, connect the dots, and remember so much better.
You know the feeling of making something with your own two hands? The joy and satisfaction it brings you. That is what pushes me forward to do more.
Yeah, it has given me happiness and confidence. Like I found myself, my passion for technology.
I just love colors. Every time I paint, I feel powerful. It is a form of expression for me, almost therapeutic. Here, I have always been encouraged to cultivate and harbor this artistic side of mine. And it's not just art, but music, dance, photography, and much more. Here, we get the space to explore all our passions.
College teaches you to see beyond your capabilities, to visualize the unthinkable and catch the unachievable. Life gives you certain opportunities to build your life, but college gives you the platform to live your life. Here, we share our memories, our stories, and our happiness. And it's a roller coaster of emotions. And before you know it, you'll realize that they have turned from friends into family. It isn't always about books, labs, and assignments. Academics are important, but there's definitely more to education than that. It's about finding yourself, about who you really are. It's about carving your own path. In this process of learning and growing, you build your own future. And then by the time it's all over, you realize that you're yet to explore so much more. What seems like the end is just a beginning. Come, find your beginning with us.
We can
Hello,
wait 2
Priya.
more minutes. Sir.
Yeah.
Good evening, ladies and gentlemen. I am Priya Shaji, the scholar of St. Joseph's College of Engineering and Technology, PALAI, and I will be your host throughout this section. Welcome to the day of the ICT Training and Learning Academy online faculty development program on Next in AI, Innovations in Machine Learning, Deep Learning, and Generative Models. This prestigious event is organized by the Artificial Intelligence and Data Science Department of St. Joseph's College of Engineering and Technology, PALAI. This section, which is section number 5 of the program, focuses on application on deep learning architectures and models. Today, in this section, we will explore practical applications of deep learning architectures and models across various domains. Before we start, I would like to introduce the chair for today's section, Ms. Neetu Tom, Assistant Professor in the Department of Artificial Intelligence and Data Science at St. Joseph's College of Engineering and Technology, PALAI. She is a dedicated teacher and a strong supporter of innovation and learning in the field of AI and data science. She will guide us through this section. Thank you, Ms. Neetu, for joining us today. Now, I'm excited to introduce our esteemed speaker, Dr. Sujitra MS. It's our privilege to welcome back Dr. Sujitra, a distinguished researcher and assistant professor at IIIT Kottayam, who delivered an exceptional section yesterday. With a PhD in computer science from Amrita Vishwa Vidyapeetham and over a decade of academic and industry experience, she specializes in data mining, machine learning, deep learning, and AI applications in agriculture. Renowned for her impactful projects, scholarly achievements, and leadership in AI-focused initiatives, Dr. Sujitra continues to drive innovation in the field. We are honored to have her with us again to show her expertise on applications on deep learning architectures and models. Please join me in extending a warm and professional welcome to Dr. Sujitra MS. Over to you, ma'am.
Thank you. Thank you for this introduction. Yeah. Hope I am audible, right?
Yes, ma'am, you're audible.
Ma'am.
Yeah, I will share my screen first. Is the slide visible?
Yes.
Yeah. Once again, thank you for this invitation. And yesterday we had completed one session. Yeah, that time participant strength was like 300 above, right, sir? Now it is not reached to 100, right? So
yeah, they will join.
Yeah, fine. Yeah, a very good evening to one and all. Yeah, yesterday our topic was like introducing the concepts of deep learning and deep learning architectures. Then it's more different models in that area that we had discussed in yesterday's session. But I need to tell you, like, we can't explain each and every portions of deep learning. I can give you an overview of deep learning only. So yesterday we had completed CNN related models, and what is the working happening behind CNN. Then what is the concept behind autoencoders, right? We had discussed about the GAN not in detail. That's why I'm telling, if I am going to talk about one topic, it will take more time. So you need to explore more on these areas, deep learning architectures. Again, I'm telling those who are going with a deep learning, you should get thorough knowledge in neural network concept. Okay, then you can move with any deep learning concept. Okay, so today I'm going to discuss some applications and practical sessions on deep learning. Okay, so first I need to tell you, yeah, if this type of images and there is a recognition for that particular object in an image, then that type of problems is coming under visual recognition. It is not just like finding the object. Yeah, you can see the names also, right? So identifying object, and we are giving the name for that object. So that all these things are possible because of that deep learning concept, that computer vision. Yesterday our talk was mainly related with computer vision, right? So this type of object detection can possible. So it's coming under an application called visual recognition. So this is also same category, visual recognition. We are giving an object and we are identifying the person or identifying the car and its name. The person also we are identifying with name. So that type of identification is happening. Then these type of problems are coming under visual recognition. So these are one of the application. But that is one area. Come with the vision, we can do this type of things, recognition, classification, and like the applications are possible. But what is this type of problem? Here we are describing the image. That also here we are giving input as image. I have discussed, like, if you are going with image data or audio, video, then only this type of heavy deep learning concepts are required. So here this is not an application of visual recognition or visual classification. This is purely an example that is describing that picture. So it's coming under text or that natural languages processing or converting that images into some letters, right? So that is describing that image. So this is also coming under the application of deep learning. You are giving a picture to your model that is recognizing as a child in a helmet is riding a bike. The next picture is a group of people are walking on a busy street. So this is a different type of application describing images. So that also possible with any CNN autoencoder or any NLP related BERT models or something. We can. This is simple an example for NLP, natural language processing. That is conversion, language translators. Okay, the code it is given as input is some Chinese or some language, but that is converting to English language. So these all the things are happening because of the natural language processing with the help of deep learning techniques. Yeah. So another category, if you are moving with speech, audio, we are saying a word called hello, the sound wave will be there. that we are giving to a neural network or CNN or any deep learning model, and it is predicting as a plain text hello. So speech recognition, that also one of the application for any application of deep learning. Facial, I'm not explaining everything, but I want to tell you the facial recognition or forecasting. Yesterday I told the LSTM we can use for weather forecasting, the stock market prediction, and also one of the area for that time series prediction. For that also, there are also huge amount of numerical data available. Because of that availability, we can apply some suitable that time series models in deep learning. So that is also possible. Music composition, real-time translation. That means Google translators, like all these things are possible. Applications are possible in the area of deep learning. Okay. Particularly, I'm going to discuss a area, an interdisciplinary area, agriculture area. Why I'm telling about agriculture and deep learning? I'm an expert from agriculture area. I'm doing the research in agriculture. So that's why I can give you more input in that area. So I want to tell you, if you are going with that area, application, if you are applying deep learning, convolutional neural network, okay, the very first one we had discussed is convolutional neural network. If we are moving with any simple data, then there is no need of moving with CNN. The data involved in that agriculture field is containing some remote sensing data or hyperspectral data or that lidar or that satellite images, images or like drone images, that type of images are there, X-ray images are there, then only you need to move with CNN. So data may be from numerical background that is shadowed like temperature, solar information, irrigation, fertilizers, that type of information numerical. That is not enough for a detailed analysis with deep learning. You can use some remote sensing data that is might be coming from that areas like set that hyperspectral images, lidar images, X-ray images. This all area we can add, we can collect the images. Okay, that we are giving to CNN or any deep learning model. Then there are a lot of applications are there. We are moving with crop classification or phenology recognition, disease detection, fruit counting, yield prediction. That is part of plan. Likewise, animal, land area, or a mechanization area, everywhere we can use this type of application. You can see this example also. We are giving some land. That land is particularly, you can see, if it is forest, a dark green is there. How it is possible to identify that location? That's one question, right? If you are checking on that picture, we can't easily recognize that might be an image from satellite, might be a drone image. From that image, they are identifying the position. That pink one is sugar beet. Okay, that the yellow one is sunflower. We are giving some information or inferring some information from this picture. Easily we can infer. That is mainly because of identifying the person's object detection. So that is possible because of this deep learning data. Or if you are using a phenology recognition, this CNN is easily we can use for phenology and recognition. Cotton or pepper or corn, if you are taking any crop, like in the picture, all are in different stages. Okay, from each stage we need to identify it as it is corn or it is pepper, it is cotton. How it is possible? That phenology we can identify with the help of different CNN. Okay. So this is the methodology we can apply for any application, any interdisciplinary application. This is very common and well known in agriculture area, like disease prediction, that leaf disease or any other type of disease. If you are giving image, you can easily identify that type of problem. Yeah. So that the same area, weed or pest identification, if you want, that is possible. And one interesting problem you can see here, if you are giving a picture of a mango tree, you can count the fruits in that tree. That fruit counting, that is possible. All these things are identifying the objects. Okay, so your duty is to identify the proper problem and identify the method for solving that problem. If it is a problem of fruit counting, you need to understand which deep learning method is that more suitable. For that, thorough knowledge is required, proper study is required. So you can adopt any deep learning algorithm. Nowadays, all the codes are readily available. Just you can try it out. If you are going for a research only, you need to be more focused and more input you need to require, more methodology, novelty is required, all these things. If you are trying to find a solution in CNN, you can take any problem and you can apply any suitable deep learning algorithm for this type of applications, right? Yeah. Yesterday, yeah, before moving to this one, can I move with some problems? That means lab session. Is it okay? If I am moving with some lab session, is it fine for you? Yeah,
Ma'am.
yeah, yeah. So I'm sharing some. Yeah, is this screens Google Colab screens are visible?
Yes, ma'am.
Yes, ma'am.
Yeah. So here one problem is that just types where I stopped is based on CNN or deep learning basic models image classifications are possible. Yeah. I hope you can see this that Google Colab page. Just I'm discussing
Hello.
only. I'm not trying to do everything. Why the time you
Hello.
know the time. Yeah. Tell me what happened.
Mama.
Any doubt?
And
I will kindly
Yeah.
request everyone to mute their microphones, please. Thank you.
Yeah. So here I'm discussing about a data set called Fashion MNST data set. Sorry to say, please unmute and ask. If anything is there, you can unmute and ask. Otherwise, you please mute by yourself. Yeah, some disturbance are coming. Yeah, fine. Yeah, so this is a clothing classification problem. Okay, the data set is Fashion MNST data set. Yeah, we are here implementing that problem with the help of CNN. That for that I'm using Keras, TensorFlow, and everything I'm using here. So here the problem is cloth classification from images. That purely an e-commerce online advertisement application. Here we need to identify the similar clothing from large set of images. Okay, so we are predicting the outfit. Okay, whether it is shirt or shoes or that type of things we need to clothing, not clothing itself, whatever accessories we can give, that we can give. So we are the CNN application we are using here, CNN implementation we are using here to classify this clothing session, yeah, or e-commerce application. For that, I'm using TensorFlow. Okay, those who are in the area of deep learning, you can easily understand this type of tools are the TensorFlow, Keras, or tools like PyTorch, Theano, all so many tools are there. Okay, those who are going for in the study in deep learning, you need to move with uh, all the tutorials regarding this type of tools. Okay, so here I'm using TensorFlow, then NumPy, that is related with Python. You can easily understand Matplotlib. All these things are related with Python only. Okay, so we need to load the data set easily. I'm using Keras application to upload the data from that Fashion MNIST. Okay, this type of benchmark data are available, readily available, that you can easily use for our small exercise programs. Okay, this is you can consider as an exercise, right? So here I am loading the data set. You can see how I'm loading using the TensorFlow. Keras dataset, that Fashion MNIST dataset is there that I'm loading, and it is naming as some data for training purpose, some data for testing purpose. So that is my duty, and I did it, and that uploaded the data. So if you want to visualize the data, already I told it's an image clothing data, right? So if you want to visualize the data, you can print the details, or you can take the data and you can put labels. Here I put labels and everything. I will show you what is there in the picture. Yeah, one picture that I'm giving some labels for the images. It might be t-shirt, trouser, pullover, dress, coat, sandal. Please mute. Yeah. Sandal, shirt, sneaker, bag, ankle boot. So many things I can label, right? So I am giving some labels for the data, and my duty is to take one image. Okay, it is not possible to display all the image. I'm just taking one image for this data. You can easily understand where I'm storing my data. X train, Y train, all these things are there, right? So there I need to take one information. So you can see here, I'm putting one index as 5. Okay, index as 5, and what I'm doing is I'm taking image index from this Y train. That data, I'm taking that data from Y train, and what is that in that picture? I'm showing X train image index. Okay, X train image index. X train is my training data, Y train is my labeling and everything. So for that image indexing, I'm showing that picture from the that huge amount of data. Yeah, so that I'm taking this one pullover. Okay, so that image I'm taking is pullover based on that index I gave. Image index I gave as 5. Based on that, I'm taking one image. So this is just for to showing you that what are the images in that picture, in that data set. Pullover data is there, right? Likewise, for me, image pictures are there. Here, my duty is to, if I am giving a picture, that need to predict correct name for that picture. If I am giving a shoe, that need to be predicted shoe. Okay, for the, what is the method I can use for that implementation? You can see here TensorFlow, Keras, layers. I'm importing dense, convolution, max pooling, dropout, flatten. I hope you can understand these words' meaning. Yesterday we had discussed regarding what is convolution, max pooling, and then dropout, flatten. Dropout is the word I just explained with 1 or 2 sentences, right? You can understand. That also very important for any layering. That if you are checking the dropout only, you can check the accuracy of that model, right? So for that, I'm setting a sequential layers. So that's why I'm adding sequential. Then how I am adding that sequential model? First, I am adding a convolution layers with the filter 64, kernel size and padding, activation function ReLU. What is the size of the neurons in that layer convolution? Then again, after convolution, I'm adding max pooling. Then some dropout is adding in between. Again, I am adding a convolution layer, max pooling, dropout. Yesterday also we had discussed about this layer setting, how many layers we can add, all these things, right? Same way in TensorFlow also, I'm adding all these things. Finally, I need to be done flatten. Hope you remember that word flatten. Whatever layers I have added, it's not a matter. After that, you need to convert the data in a flattened format. That has happened here. Here I flattened the data, then I applied the, what was after flattening, what we need to apply? If anyone remembering yesterday's session, you can answer. After flattening the information,
fully connected layers.
Yeah, fully connected layer. Thank you. So fully connected layer, that is representing with dense. Here one dense is the second dense is the, so all these things are representing fully connected layer with activation function, that ReLU, the softmax. Each layer you can set any activation function. So this is the model I'm going to create. Then that model summary, if you want, that will be printing here. So that model summary is there. So the model is explaining what is there in each layer, what are the settings, all these things, how many parameters are there, all these things are there. Yeah. Then I want to do what once model is there, we need to get the optimum result. Okay, deep learning also same strategy. Yesterday I missed out that portion. Optimization. Optimization is possible with so many methods. In that grade, in your backpropagation and everything, gradient approaches are there. Gradient based learning is there. Likewise, some Adam optimization. So many other optimization methods are. That is mainly for tuning your algorithm and getting the best result. So here I'm setting some optimizers in that model, and I'm fitting that model. So that model is ready with all the optimization and everything. Then I have the X-trained data, I have the Y-trained data. I can set how many epochs that iterations are there to check the optimization with the batch size, how many, what is the validation split, all these things you can set. I'm not explaining each and every parameter. You need to understand these are the settings for all these things. Okay, so based on your problem, it will vary. Okay, once you are there in your work for deep learning, you need to understand each and every component of any function. Okay, so this model is fitting with this information. That is X train and Y train. So that process epoch is happening, all these things happening, loss and everything. Then some convergence point will be there, like optimal result where it is resting with an accuracy 0.89%. That is training accuracy. Okay, that is training accuracy only 0.89%. Then I want to calculate loss in case of testing. So for that, I'm using the testing information. Already I took the data in two formats. One is for training, another is for testing. So here I'm using the testing information. There I can find the accuracy as the accuracy. It is 87. That means 0.87%. So one model, okay, good. It's not for any research purpose. I didn't want to prove any novelty, right? So I can give some accuracy 89 and 87, like considering it as a exercise. Okay, hope you understand the methodology, like what we are creating, how we are creating a model, how we are calculating accuracy. So that evaluation is over. We can move with is a pure classification problem, right? So accuracy only you need to take. Okay, so then we can plot the things with the help of accuracy and everything. You can see easily understand what is the training accuracy and what is validation accuracy, yeah, in each epoch. Okay, so then after all these things, you can just give sample data. Here you can give test information for some random prediction. So here you are predicting the information. You can see what is happening here. I'm predicting. You can see model dot predict. This is statement model dot predict. Then predicted information will be here, but I want to display it as it is an image. So I am randomly selecting all the things and I'm just printing what is there in that prediction. Definitely it will not be correct. Why? Only 87% accuracy. Yeah, you can see so many different. Yeah, pullover is correctly predicted as pullover. It is dress is predicted as dress. There's so many. Trousers is predicted as trousers. Some bags are predicted as bags. That angle board, everything you can see here. But the issue is, any missing is there? Might be somewhere. What is called sandal, trouser? Yeah, yeah, perfectly for this information. I just randomly only before starting the session. So this one is correct because any missing is there? No, I hope there is no missing. Everything is correctly predicted. It's not possible if you are giving more information. Why that 89% accuracy is there, right? So some information, if it is wrong, that will be displayed in different color. I gave the code also here. You can see green. If it is dress is perfectly matching dress, it will be printing. Otherwise, if it is not true, it will printing red. By luckily, all these things that printed is same. That's why it is not providing any red color. Okay, hope it's clear to you, right? For this discussion, anybody has any doubt? If any doubt is there, you can ask. Stop. Anybody has any doubt, or if it is need to be slowed down, I can slow down. Please respond. Is it fine?
And some people are responding in the chat box.
Yeah, I'm checking on it.
Okay.
Is it? Yeah, the previous session, is it queries in this session? I didn't check the queries, right? Google Colab and everything I will share to you, our coordinators. Okay, I'm just explaining only. It's not possible to hand-on and hands-on session is not possible now, right? That's why the optimizer Adam can be replaced. Yeah, any suitable deep learning suitable algorithms you can use. Sparse categorical cross entropy. Yeah, that's very good question. Cross entropy. You heard about the word like MSE, that mean square error, mean absolute error, that type of words, right? So that is okay for any loss calculation with numerical information. Okay, that coarse entropy, that is providing more accuracy in the deep learning case. That means maximum likelihood only they are checking. So for deep learning purpose, most of them following cross entropy, that entropy related loss functions. That reason mainly that is following with maximum likelihood of that calculation, not like mean absolute error or mean squared error. Yeah. So fine. I will share you all these links. Okay, later. If all are correctly predicted, then how it is 84%? That I'm telling. This is not. I'm just randomly pick some numbers. Okay, that for that image I'm randomly only select some selection is happening. By luckily only this happened as all things are correct. If you are doing the same code, then it will not be same as my result. Okay, so hope it's clear. Yeah, hope it's clear. Yeah, fine. Okay. Yeah. So yeah, Shall I move to next explanation regarding the lab? Yeah. One more example I need to tell you. It's this example, the previous example, just based on that image, right? Just I'm giving one image and everything. But I want to tell you that VGG and everything you can use with some application related with that that called images transfer learning. Have you heard that word, transfer learning? Some of you might heard about that word, transfer learning. So that type of application we are using just that cotton image example I am telling with VGG16. Okay, hope the screen is visible.
Yes, ma'am.
Yeah. So yesterday I told you about VGG16. The previous example is connected with the CNN. And I am explaining about the VGG16 or VGG19. Okay, these things also we can use with this image explanations. Just in this, yeah. So here you can see what happened. Yeah. Yeah. Here you can see that we are using some TensorFlow and everything that I am not explaining again. And Keras, from that Kera, I'm using the packages like not sequential. In the previous example, that model was like sequential model and the convolutional layers I have added. Here, readily available VGG16 and VGG19, everything is there. So that's why I'm adding that from the Keras, I'm adding that one. So here I'm just using cotton disease prediction. Okay, cotton disease prediction in the sense what is the percentage I'm obtaining, accuracy I'm obtaining. So that I'm going to check with cotton disease data. That also readily available in Google, Kaggle's data set and everywhere it is available. If it is not available, also I can share with FDP coordinators. Okay, so that VGG16, the model I need to create same as that previous one. Then weight I am taking from image data and information. All these things are readily available, and I can give all the information in the VGG16 model building. Okay, and prediction and what I am doing, you can see after flatten for VGG16 also flatten is there, but here you can see I'm not telling anything regarding convolutions. Okay, I didn't set any convolution layer or pooling layer or nothing. I didn't set here. What the reason mainly is a readily available package that VGG16, VGG19. If I am using sequential model only, I need to add the layers and everything. Okay, here readily available and the model that is directly calling with VGG16. The model is easily you can develop. Just add the image input into this problem. That is enough. Okay, so here the data I flatten and dense layers it is required. We need to set dense layers. This model is there, right? Model, but you can see here once printing the model, I didn't tell anything regarding convolution, max pooling and everything, but automatically the model is containing all these things. That is the format it built with VGG16. To convolution max loading, to convolution max pooling, to convolution, etc. All the settings are there. Whatever thing we mentioned is here only how to flatten, what is the combination of dense layer. That only I had to mention. So based on that, I can give the data set generated from image data generator. I can give that data that is already, I can generate the data like cotton disease data for training and testing. If it is available in your laptop, you can take it. Like you can give the path here. Okay, if it is readily available in Kaggle data repository. So that test data, all these things you can give here. Here, then again, and testing is happening. Model test setting is there. Model building is there. You can see here. I'm fitting the model, training set, validation, epoch, and everything I can give here. So epoch, iterations, everything happened. Then I'm plotting here loss function. Okay, just using the loss function. How I want to provide the accuracy and everything. Okay, so that I'm just printing the accuracy here. You can see here train loss and test loss and training accuracy, validation accuracy. Okay, so this type of printing is simply helping you to plot the things. Why I'm showing this is you can use you will be more printing the images is more complicated thing. Okay, you need to understand how images are coming and everything. Without that also you can check accuracy. Okay, here I didn't upload any image. Okay, just try with the data set uploaded and train data, test data. That only I used. Then I directly printing the things. If you are a beginner in this area, just check the accuracy. Then you can move with the image printing and everything. Okay, those are not aware about how to handle with images, you can move with just accuracy check and everything. So that is the beauty of this type of readily available packages. Here we used VGG 16. Okay, I hope it's clear. Whatever things are required that you can print it out, accuracy and everything, you can print it out. Just for the information, I gave this explanation. So the previous examination, you can use, might see like all the layers, convolution layers, all the layers I have given. But here I didn't give anything. But the model is readily available that you can use and just check the accuracy by uploading the images. Okay. Yeah. So same scenario with cotton disease, we can apply with some convolutional neural network or any the image representations also. So the it will be different. Yeah, you can print the image. Okay, if you are going for any research work or anything, that should be matter. Which one? Presenting a paper, right? So that time that pictorial representation need to be considered. So whatever things you are uploading, that you need to print out. Here you can see this is a cotton leaf with disease. Yeah, that image is there. Cotton leaf image is there. Then this is a cotton plant with the disease. It's not a good plant, right? Cotton plant with disease. This is a fresh cotton leaf. Okay, fresh cotton leaf is there. Then this is a fresh cotton plant. Okay, so how we are uploading that images to your platform, that is very important. Okay, the data is there, easily you can understand the cotton disease data is there in Drive, and then how you are uploading that with image size, cotton, how we are showing that labeling and everything you need to understand. Then easily the output side printing also it will be okay, right? So then I'm not explaining again from a convolutional neural network. Here I can create a model, CNN model, as I mentioned in the previous example. Here also CNN model is there. Whatever layers are secured, I can add it and fit the model. Then we need to check the accuracy and everything, and model loss, everything we can check. Then what is the things required for printing, that also you can do it. Okay, the previous that image is not loaded here, but the thing will be you can give one picture and the picture will be depicting like this is the cotton plant with disease, this is a cotton plant without disease, like that it can that label will be there. Okay, that type of explanations are possible in the case of convolutional neural network classification. Yeah, one more example I want to show you. Yeah, here the data is something like yeah, here also I am using the keras, TensorFlow and everything for these things. Here I am taking some vegetable images. Okay, first I will show you the images I am taking. You can see here cauliflower, potato, radish, pumpkin, tomato, papaya, broccoli, so many, right? Bottle gourd, carrot, cucumber, cabbage, bean, bitter gourd, capsicum. So this is a data set, vegetable data set. It contains 20,000 images, right? So if I am explaining with lab session, it is not possible to upload from yourself. You can download it from any website that readily available vegetable image data set, that then you need to download it to your system, then you need to upload to your platform. If you are moving with Google Colab, in Google Colab, you need to upload that things. So the type of data set is there, right? Then I'm preparing my data as training data, validation data, test data, that type of splitting I am giving here. Okay, and that easily you can understand how we are taking the data. So some images, 7,000 images are there in different 15 classes. That type of images, so many images are there for training, testing, and validation. Like previous example, here also I have set a one convolution neural network model. So here the explanation for convolution neural network summary is there. Then I fit the model with my data. Yeah, trained with the different epochs. Okay, that is not displayed here anyway. Yeah, so I want to show you if I'm giving a test image. Yeah, I'm giving tomato here. Yeah, just before your session only I run it. Yeah, its predicted label is tomato. The actual level is actually broccoli, but my program can't understand that it is broccoli because my accuracy rate is something like, what is my accuracy that I need to check? Yeah, only 51%. Okay, accuracy testing accuracy only 51%. So there is chance of getting this wrong answers. Okay, that is possible. You need to tune the model or regularize your model, apply more good optimization methods. Okay, that all the techniques are there. Here I am directly given the information and I got an accuracy of 51%. Yeah. So if I am giving, oh yeah, another data I gave is cucumber. Oh, that is predicted as bean. Okay. Yeah, one correct answer is there. Potato I gave and actual label is potato. Yeah. This is not a big issue, right? Cucumber is considering as bean. The bean is considered as cucumber. So it's a mistake, right? So that recognition mistakes are there because 51% accuracy is there, but some is predicted as potato. So this type of applications are okay possible. This type of classifications are possible with CNN related method, VGG, the transfer learning. That type of things are okay with this type of applications. Anybody has any doubt? Please text in chat box.
No, ma'am.
Yeah, fine. So just an explanation. I will share the Google Colab code and everything. No issue. I'll share with your coordinators. Okay. Within 1.5 session, we can do all the lab practicals and everything. That's why I will share all these things. Okay. So then I want to come to my PPT part. Hope some idea is there how to build a CNN, how to build a network, how to add the things, and how to upload your image. Then images, how to predict all these things. So mainly all these applications are practical session. That sorry, classification problems. These type of problems are coming under this area. But if you are moving with GAN related information, okay, or other algorithm, autoencoder. Yesterday we had discussed about that. That area is different. Okay, that area is different in the sense it will be having different type of problem. If you are moving with CNN, it will be having classification problem. If you are moving with GAN, it will be having different scenario. Okay, or if you are using autoencoder, that will be different scenario. So some examples we will discuss here. Okay, that all these things we can't do with the lab experiments. That's why I'm added in between some possibilities. You can work it on any algorithm. Okay, this slide onwards, I am discussing about different applications of different algorithms. Okay, here is a GAN problem. Okay, yesterday I told GAN is mainly for generated phases. Okay, here what is happening? A man with glass is there. You can see in the picture, right? Sorry. Yeah, a man with man with glass is here. Then man without glass is there, plus woman without glass. So all this data set we can give to our core algorithm. So yesterday I mentioned you what is the two main things happening in GAN. In autoencoder, it's encoding and decoding. GAN, what is the two terms? What are the two terms we used? Anyone remembering that words? Sorry?
To realize the images, whether it's a fake or real.
Yeah, fine. But generator and discriminator. That word was there, right?
Okay.
Yeah. The application is fake or not, we can check. That is based on that generation and discriminator part. Okay. So anyway, yeah, where is my slide? Yeah, here also I'm generating woman with glass from man with glass and man without glass combination, then woman without glass. All this combination I gave and I generated from that woman without glass. So this type of applications is possible. It's an example of vector arithmetic for GAN. There we can see the picture arranged in a vector value. It's an unsupervised method and with deep convolutional generative adversarial network. Deep convolutional. Okay, here also that word is the convolutional concept is there for any algorithm, but it is coming under its GAN application. Then it is different. It is vector arithmetic. The previous example was vector arithmetic application. Here, photorealistic GAN. Yeah, taken that photo and we are creating a different versions of that photo. You can generate different realistic photo, generated faces. Okay, from different photo we can generate different faces. Okay, so that is the then generate cartoon characters. Okay, one photo will be there. We are not taking so many clips of that cartoon character. It is generating. Okay, you can see here how we can generate different styles of uh, cartoon character faces, right? So that is possible because it's anime characters, automatic anime character creation with the GAN. Okay, so that some comic books will be there. One character is there. If you want to replicate that thing, you can use this type of GAN concept, generative adversarial network concept. Yeah, that means if we are giving some input here, sample images, different release years. So another category we can next year we can create different styles of images. That cartoon character is not real, right? So but with different emotions, different pictures we can produce, right? Yeah, that is one application of GAN. Okay, then image to image translation. Yeah, like translation of semantic image to photographs building, translation of satellite photograph to Google Map, translation of photos from day to night, or black and white photo to color, sketches to color photograph. This type of translation that is possible with GAN. How it is possible, you need to thoroughly understand that GAN algorithm and you need to apply that methods. Okay, so that pixel to pixel classification and everything, translations are there. Okay, so that is also coming under image to image translation. Yeah, one example you can see here, image to image translation. I'm giving some input of day, right? You can see here. Output is something like evening stage, right? Same area, but for that I need to give some ground truth. What I need to convert for that, some ground truth I need to give. That based on that ground truth only this type of conversions are happening. Here it's image to image translation with the help of I told you that different styles of GAN is there. You see here it is conditional adversarial network. So daytimes it escapes to nighttime. Daytime city area and how we are representing in nighttime with the help of some ground truth. This ground truth, you know, that area how it is looking like in night, that we know already we have. Based on that only one picture that is not the correct picture of this input image, but for that particular input image what output should be generated, what how the night image will be looking like, that we can generate with the GAN, but we need to provide some ground truth. Okay, you need to provide some ground truth for this explanation, this conversion. Yeah. So that here one more example. Sketch we can give to color photograph. Some sketch we can give like bags, sneakers, shoes, and everything. You can give some sketches. We can convert. It's a good one, right? That with the help of Pix2Pix platform. Okay, Pix2Pix platform is there. Yeah. So that I'm not going with details, but I want to tell you this type of sketches to photograph. If anyone is interested in this type of area, you can work it out. Okay, so color photograph, sorry, sketches we are converting to color photographs. Yeah. Then another category of GAN is cycle GAN. Okay, cycle GAN, it demonstrates different translations like photograph to artistic painting style. The type of application you are familiar now. We are giving some photograph, it will be converting like painting style. Then translation of horse to zebra. Translation of photograph from summer to winter. Now you can see that age variation pictures and everything, right? That different ages is going like childhood to that old age photos are there, right? That satellite photograph to Google Map view. Okay, so that is basically with the help of cycle GAN. There also the same thing is happening, image to image translation. But it is
ಪ್ಯಾನ್ ಕಾರ್ಡ್ ಫೋಟೋ ಕರೆಕ್ಟ್ ಅಪ್ಡೇಟ್ ಆಗಿದೆಯಾ?
Yeah, can you please mute? Yeah, cycle consistent adversarial network. That type of cycle GAN is introduced. That concept is there. Because of that, this type of translations are possible. Yeah. Yeah, you can see here some input image is there, the output is what? Right, input is there like it's a horse, but it is converted to zebra. Okay, some reconstruction happened right in between. So likewise, some input where real image is converting to artistic image, artistic image is converted to photograph. That is possible with the help of cycle GAN concept. Okay, yeah. Then text to image conversion. That is a good idea, right? Text to image translation. It is mainly based on stack GAN. Inside in GAN itself, stack GAN is the text to photo that you can see here. The small bird has a red head with feathers that fade from red to gray from head to tail. This is a word, a sentence I can give. So you can see how the stages are there as output. Each and every stage it is giving the correct output, right? The second stage, the second question, this bird is black with green and has very short beak. My system is identifying and it is generating that type of images. Yeah, it's good, right? Yeah, we can search it with Google and Google is telling all these things, right? That is there, but our program, if it is implementing like this, it's going to be like, yeah, something we did, like that feeling will be there, right? So you just try this type of stack and everything. You are giving text and that is converting to image, text to photorealistic image synthesis. Yeah, that also generate realistic looking photograph from textual description of simple objects like birds and flowers. Regarding flowers also we can give some explanation that is converting. So this is text to image. Okay. Yeah. Here, the one more example is here. That is also text to image synthesis. Like this small bird has pink breast and crown and black primaries and secondaries. That only I can give, but the result is there, right? Then this magnificent fellow is almost all black with red crest and white cheek patch. That figure is there. If it is a flower, I can tell like this white and yellow flower have thin white petals and a round yellow stem. Yeah, result is there. So that text to image translations are possible. Then here, yeah, this is different scenario. This bird is completely black that I'm giving. Okay, this bird is bright blue. So that time I'm checking what are the features they are explaining. Yeah, it weak is I'm not telling, or I'm not telling about right leg. I'm not telling about belly, but I can tell you like some. This bird is bright blue. Okay, so here you can see one example. A man in orange jacket, a black pant, and black cap, wearing sunglasses, killing. I didn't mention about the head. All the things are there, but head is not there. Yeah, all these areas are there to study or for the research purpose. It is there. I didn't mention about the head, but that head is not there in that picture. Yeah, but all the cap and sunglass, everything is there. Right. So that type of studies have happened in these papers, like that first paper tag GAN, text conditional auxiliary classifier, generative GAN, then learning what and where to draw. That was different style of GAN concept. Okay, so all these applications are coming under GAN. Then you can see here semantic image to auto translation. This is a semantic image that means all the informations are identified. The
Hello, ma'am. Hello, ma'am.
Voice is not audible.
Hello, Sujitra, ma'am. We can wait. She'll be back. I called her. She'll be back in 1 minute.
Am I audible now?
Yeah, ma'am. Audible.
Yeah. Where did I stop? Can you tell? Which slide I stop? Can you? I will share the screen and please tell me which slide I stop. Okay. Did I reach here?
No.
No, ma'am.
No, ma'am.
This one?
No.
This one?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Yeah. Sorry for that confusion. Okay. So that another application you can see here in the picture, like the front view generations are possible. Here in the picture, they are giving the side pose and generating the front side. How it is possible? That is based on the face rotation only, but it is not a person. It is not a real human. That picture itself rotating and demonstrating that this is the person, front view of that person. How it is possible? Mainly because of this GAN concept. Okay, this idea is that generated front on photos can then be used for input to face verification or face identification, right? It is very good for any cyber crime or anything. If you are getting side pose, if it is generating the front pose of that image. Yeah, another application is generating the poses. Okay, I can generate the poses from one picture, but we need to give the target pose. You can see in the picture, first picture, the lady is the looking on front side, right? But the image, target image I am giving is a side one, right? You can see one target dotted image that I'm giving as an input. From that, I'm generating the pose like side poses. Okay, so it is possible. Here the back pose is there, but I'm giving as a front pose. Then the target output definitely the front image. Can you guess how it is possible with the current technologies that you need to check, right? Okay, the person pose is we can change with the help of target. image. So that type of generations are possible. Right. Here also you can see the same scenario. We are giving some different pose, and the picture you can see, second one you can see here, one lady is there, but the target pose you can see her leg position is different. Based on that, I can generate, GAN can generate the pictures poses. Okay, these are applications coming under GAN image generations. Okay, but same way we can remove the something from that image also. That is one paper image retraining using the same generative adversarial network. That one picture rain is there, that GAN is removing the rain. Okay, then second some snow is there, that I'm removing from the picture. Okay, so that is how it is possible, that generation is possible, likewise removing the some particle from the picture also possible. So all these are coming under the applications of GAN. So for that, the methodology will be there, right? For all the generation, that I will tell you with one example here. If I am giving a real underwater image, we have already that existing data will be there. That image I can give and some ground truth I can give. So generator will be there. Okay, that means you can see the picture. A heavy network, heavy neural network will be there. That is the principle of that generator. Then we are checking with a fake target. Okay, then I have real underwater image, another one plus ground truth. That also there. That I am feeding to discriminator. Then discriminator is telling whether it is real or fake based on the concept of ground truth. Okay, so that is possible with the help of generator and discriminator. All these things are happening based on these two concepts. So you have to learn how to write an algorithm in generator, how to write an algorithm in discriminator to check whether it is real or fake. Okay, so there are also accuracy checking, that accuracy measurement and checking and everything is there. Yeah, the real underwater image is there. Then one ground truth is there. The GAN result you can see. Okay, so all these things are the example of that underwater project. Okay, yeah. So then definitely if you are going as a research, you need to create a model and you need to check with accuracies. Okay, so here different models are there, GAN models are there. Its ratio, it is not simply like what simple results like MSE result or mean absolute error or any entropy, not like that. You need to check the proper. I hope you know IOU word. If you are going with segmentation and everything, you will check YOLO model and everything. You will check in that intersection or unit IOU factor. Likewise, for GAN also the PSNR, SSIM, that factors are there to check the accuracy and all. So that you need to study and you need to use the proper measure to check the GAN models. Okay, so that is regarding GAN. Likewise, again, mainly generating the faces, generating the poses, removing some particle like that. Here I am discussing about, next I am discussing about object detection using deep learning. That also coming under the area deep learning, object detection. For that, have you heard the word YOLO? Can you expand the word YOLO?
You only look once.
Yeah. Yes. Find some my questions or doubt, please.
Ma'am, what is the principle behind a generator?
A generator. Yes, I told you now. Generator is generating the mainly one neural network architecture will be there. Okay, one neural network architecture with proper settings will be there. That is generating the image from this ground truth. Already we had one image, and the ground truth image is there. From that we are generating one image.
The
That
input image is called as a ground.
Sorry, I didn't get you.
The input image is called as a ground truth. Yes, ma'am. Is it? Ground truth means?
Ma'am, I think your mic is muted.
How it has happened? Yeah. Yeah, which point I stopped. She asked one question, whether she heard the words.
Yes, ma'am. Ground truth is the input image, right?
Yeah, yeah, yeah. Yeah, listen, listen.
Thank
No. Ground truth. I just answered that query, but now only I realized that this mic was muted. Yeah, fine. We need to give some real image. Okay, for that I have to create one ground truth also. Okay, that means if you are taking one tree with proper information like real data, then that is required some particular problem statement, like some area we need to check, or some object boundaries will be there, like bounding boxes, or some area need to check. For that picture we need to provide some ground truth that we need to generate. Okay, that we need to kept in our problem, then only we can give that information's input. Okay, real images we can give, but this ground truth we need to set, and we need, there is a process for setting the ground truth. Okay, that we not consider as a input we are giving. For the checking we are setting some ground truth. Based on the problem it will vary. Some problem we can directly give, some problem we need to some segmented portions that we need to give as ground truth. Is it clear now?
Okay, yes, ma'am. Yes, ma'am.
Yeah,
Thank
yeah. Again, challenges are there, and that pros and cons everywhere it is there. Yeah, optimizers. I will share the screen with the different optimizers. Yeah, be with us. Later I will show you. Okay. Yeah, fine. Where is the slide? Yeah, so YOLO, you look only once. That algorithm, different versions are there. Mainly, this is for object detection from image. All this area, that concept like that ground truth is there. Okay, so you can understand the concept YOLO. It's a deep learning architecture. You only look once concept is a single stage detector. Okay, so I will explain with some problems in agriculture. So you need to understand here also you can see some pictures that will be like bounding box with confidence. Then it's class probability map. Then based on comparison only I'm getting the result final detection. The picture is there. Okay, I'm not telling the theory. I'm just telling this picture you can see a grid image. Okay, then there I need to find bounding boxes. How many pictures are there in that figure? One dog is there, one cycle. That I'm trying to find out bounding box. In each bounding box, I need to specify the confidence. Okay, all these are part of the algorithms, right? We need to find the bounding box first for any object detection problem. So then confidence also you need to measure. Then some class probability map also I need to create from that. By comparing that only I can final detection is possible. Okay, so that is the main concept behind YOLO. So many architectures are there. It's not possible to discuss all the architecture, but you need to understand YOLO is mainly working the principle object detection. Okay, yeah, it's fast and accurate. Then the calculations are mean, average, precision, intersection over unit. These values we need to consider based on the ground truth. Okay, for that picture, we will provide the ground truth. What will be the correct answer that we will compare, and only we can calculate all these things. Okay, yeah. So once we go get the image, you need to put it to the algorithm, find the bounding boxes, the class probability map, and all the comparisons are required. Okay. All the pictures are the same, only bounding boxes. I will show you some other examples. Object, yeah, you can see some scores here: 0.8, 0.7. Is it visible? 0.6, 0.9, 0.7.
Yes, yes, ma'am.
Yeah, so here I'm creating some bounding boxes, but I will to tell with confidence. So if this is bounding box, I have 80% confidence. If the bounding box is this 0.7 confidence, so that confidence we need to create with algorithm. Then we can predict with whether class probability map, or it is a car, it is a truck, or that type of things we can predict. Yeah, that architecture, that basic of that YOLO, and YOLO detail I am not explaining. Yeah, code is there. It is there to try and discuss that. Yeah, you can see here your YOLO model, how we are setting the model, loading the model, so that images are there. That images we need to upload. Okay, object detection function is there. Then printing whether the percentage of probability. That picture also you can see it is a dog with this much probability, cat with this much probability. Okay, 99% cat, dog 99%, cat 94%. So it's simple this pre-trained model. You all are pre-trained model. That image.I detection, import object detection. Then you can set all these things on a path and load the model. Image you can upload from the. This is a single image. Okay, from the single image, I need to use that object detection from that image, and the detected image I am telling them with the probability percentage. Okay, so that type of YOLO of P5, all these things are the same idea. I'm not discussing the code now. Same thing we can do with the webcam also. Okay, this is directly I'm giving with the images directly from video or directly from webcam. All these things, these object detections are possible. Yeah. If it is a video streaming, I'm telling if it is a video, it's a video. Just playing video. Video streaming input is there. Load the model and include the next frames. Each frame we can plot the boxes and object detection. That is happening with videos also. Frame is matters. Each frame it matters. Yeah. So if I'm just going with an explanation of that agriculture application, mainly this type of detection classifications, object detections coming based on object based and pixel based. Okay, that how it is object based and pixel based. Object based any classification. I'm just I thought I can explain all these things, but I'm roughly skipping that agriculture part and telling if it is object based classification, you can give one input image, you can apply a deep detection process, and you can detect the objects, right? So it's a two concept, two stage detector is there, one stage detector. So here also I am identifying the object of interest within an image or video by placing a bounding box. Okay, so one category of detection is object based detection. So that object detection is based on two concept, two stage detector and one stage detector. Here I'm detecting from this picture where is wheat. Wheat I am detecting. Okay. Yeah, if it is two stage, what we need to do, split the detection framework into two parts. One is for candidate region generation, then second for making classification prediction for each of these region. So two steps are there. RCCN, fast RCCN, faster RCCN, all these algorithms are working for that detection. So first we need to provide candidate region generation, then you need to making the classifications on this region. Okay, that is two stage. If you are going with one stage algorithm in object detection, that is coming under this YOLO and everything. Okay, the common method YOLO different version that only need to look at the input image once and making the detection faster. So if you are going with object detection, these two types are possible, two stage and single stage. Only need to look on the input image once taking the detection faster. Yeah. So different applications are there and accuracy, everything is there. We didn't have the time to explain everything. Then same way pixel based classifications are there. That might be semantic and instance segmentation. Okay, pixel based classification. Okay, so the semantic in the sense semantic segmentation is effective pixel based method to monitor anything with different types and every possibilities. Okay, so this algorithm aims to classify each pixels in an input image to specific class, resulting in a mask or heat map that identifies. Okay, so here each pixel we are mapping from the input image. We are mapping each pixel to a separate class. That was not there in the object detection. What was in object detection? It was like we are finding the object with the two-stage detector or single-stage detector. So this is different and semantic segmentation. Yeah. Yeah, you can see the architecture, the same input file I'm giving, the output is some segmentation. That time you can see here how much layers and how what encoding and what the decoding happening in each application. Yeah, that you can see here, right? So these much settings is required for when you are implementing your algorithm also. Yeah, and there is no that much time is not there. Yeah, otherwise we can explain the features and everything, right? Yeah. Then, this one is coming under that segmentation, semantic segmentation. All these applications are semantic segmentation and explanations. Yeah. From this picture, can you identify which one is object based and which one is pixel based? Here, the first example, easily you can recognize that boxes and everything is there. That is means mainly based on object based classification. Then right side is mainly pixel based drop classification. The segmented portions are the based on the pixel values. That's why I told that semantic segmentation. Wait, the semantics. Wait. Yeah, these both methods are applicable, semantic and instant segmentation based on the pixels. Okay, so that is the difference when while you are checking on the picture, there is no bounding boxes and everything, right? Here is converting the pixel and creating the values, right? So that creating the images, right? Yeah, I will show you some accuracy measures for all these things. Yeah, directly accuracy, precision, all these things you can apply. Apart from that, down to the IOU, you need to move it. Yeah, here also you can see this is one image. That image, how we are pixel by pixel we are converting and finding the area. This type of images, the previous example also I have shown that way, right? This type of colored images. It is possible based on this pixel based segmentations. Yeah, that's all. Yeah, winding up early because if any queries or anything is there that you can ask. Yeah, that I will explain. UAV, that satellite images will be there now. I thought I can explain more in agriculture area. That's why I put that UAV images. Yeah. Once you go through, yeah, have you seen that architecture of YOLO? Oh, yeah, that versions and the layers, number of components inside that YOLO, that is varying for each architecture. Yeah, so unit, yeah, that unit architecture, yeah, I will show you that picture. Sorry. Yeah, this type of pictures are the unit architecture. You can see this picture, right? Hope you can see. I hope you can see this picture, right? Is it visible?
Yes, ma'am.
Yeah. So yesterday we had discussed about convolution and all, right? So what the type of convolution? What type of layers are required here for feature extraction that we can mention here, right? Then again, if any convolution is required, that we can use in encoder side. That max pooling that is representing with the red arrow. Okay, the layers inside the convolution and the pooling, again convolution, pooling, again convolution, that is happening in between that connection concentration of feature map. That also the copy and crop, that means the same is we needed in decoder side. Okay, so that is happening here. After some encoding, it is directly decoding, right? That means up convolution. Up convolution is happening from here to here. Then again convolutions, up convolution, that instead of convolution, that up convolutions are happening. The same procedure is happening, and that can be ending with the convolution layers. Then final output will be there. So this we can easily explain, but how we are setting that 64, 512, 1024, all this matters. Okay, so that your code is required. You need to check the parameters in that code that is required. Okay, that is possible. Unit architecture is possible for semantic segmentation. UAE images are that unmanned aerial vehicle like drone. That type of image I am showing here. Okay, that's why I'm telling you UAV imagery, drone image or satellite image that is coming under UAV. Okay. Yeah. Any other doubts? Where is that? Yeah, that converting that image we need to convert now. That image is converting, identifying the segmented portion. All these things are happening. Yeah. Any other
Thank you,
doubt?
Dr. Suchitra, for such an enlightening section on application on deep learning architectures and model. You explain application of deep learning like visual recognition, forecasting.
One second.
Okay, sir.
Is it over?
Any doubt? Yeah, my part is over, sir. Any
Oh,
doubt
okay.
is there? Yeah.
Okay.
Yeah.
Ma'am, I asked a question on how to train my YOLO by using a custom data set.
How to train YOLO? Yeah, I will share that screen once again. Yeah. For all these things, I can just tell you that process only. Okay. Yeah. Have you seen this picture? Is it visible?
Yes, ma'am.
Yeah. So yeah, so many pre-trained. Yeah. So many pre-trained YOLO models are available. Like you can check these links for installing and all these things. Then you can see here that object detection. Yeah. Object detection file is there. That part is there that we can import, and you can upload your picture here with that what YOLO V5 that model. Here I am specifying YOLO H5, right? That model I am setting to here, and then only I am loading the model. Yeah, so that's the way we are loading to the model. I'm telling about the programming side. If it is a pre-trained model, okay, if it is a pre-trained model, directly you can use it and you can apply your image, and directly once the image is there, you can use the detection. Okay, object in detection, that output will be finding a bounding box, and bounding boxes will be displaying the probabilities. You can see here, right? So that is happening in programmatical side. But if we are in YOLO side, you need to understand the part, like how each path that I told, single stage, right? I told it is coming under single stage. Only need to look at the input image once the decision. That is happening because that each point they are checking. Okay, then finding that probability map as probability map, and then only they can predict that this much accuracy or this much precision for that picture. Okay. Once you got the idea, you can move with the algorithm part. Is it clear? On custom data set, yeah. Any data set if you are doing the algorithm part, you need to understand. I hope it's clear. Anybody has any doubt? I hope it's fine. Applications are anything you can apply, any interdisciplinary things can be applied to deep learning.
Thank you very much, ma'am.
Yeah, fine. Thank you.
So once again, thank you, ma'am, for such an enlightening section on application on deep learning architectures and model. You explain application of deep learning like visual recognition, forecasting, real-time application, object and pixel-based crop classification, etc. Your discussion on application of deep learning in agricultural field and also the practical section was very engaging and knowledgeable. This section has given us a clear understanding and inspired us to explore more. And ma'am, we are looking forward to a collaboration in the future. Thank you for your 2-day section and the effort that you took for sharing your knowledge. Now, I invite Ms. Needu Tom, the section chair, to present the virtual memento to our esteemed resource person, Dr. Sujitra MS, as a token of our appreciation.
Thank you, Priya. Am I audible?
Yes.
Thank you so much, Dr. Sujitra, for such an insightful and thoughtful, provoking session. The session was truly inspiring, and thank you for sharing your expertise and experience with us. It was truly been a privilege to you as a speaker for this session. As a token of our appreciation, we would like to present you with a virtual memento. This is a small gesture to express your valuable time and effort. Thank you, ma'am.
Thank you. So I want to tell you one thing for this 2 session. I can't explain in detail. If you have any doubt or any things need to be collaborated, you can just mail to me. Yeah, my mail ID is available in IIT Kottayam website. Just mail and ask anything is there, anything to be collaborated. Okay, you can understand for this too hectic time schedule, we can't explain everything. Okay, thank you. Thank you.
Sure, ma'am. Before we move ahead, I would like to extend my heartfelt gratitude to the speaker and participants for their contributions, making this section a resounding success. Your active engagement and insightful questions have added great value to the discussion. Thank you once again to everyone for being part of this enriching experience. As we look forward to the upcoming section, I am pleased to welcome the host for the next section, Mr. Alex Thomas. Thank you, and over to you, Alex.
So thank you, Priya. Once again, I would like to thank everyone for joining the previous section. Now we will be moving on to session 6. So good evening, everyone. Once again, welcome to the AICTE Training and Learning Academy online faculty development program on Next Gen AI, innovations in machine learning, deep learning, and generative models. We are excited to have you all here today for this wonderful opportunity to learn and explore the latest advancements in the field of artificial intelligence. It is my great pleasure to introduce today's esteemed speaker, Dr. Jisha Anujos. It is a distinct pleasure to welcome back Dr. Jisha Anujos, who captivated us with her insightful session yesterday. Dr. Jisha, a senior software engineer at Quest Global, brings over 12 years of exemplary experience spanning academia, research, and industry. With a PhD specializing in digital image processing and an impressive portfolio of research contributions in machine learning, deep learning, and artificial intelligence, she has consistently demonstrated her ability to translate advanced concepts into real-world applications. Today, she will share her expertise on the topic implementing supervised learning algorithms with deep learning using images. We are indeed fortunate to have someone of her caliber to guide us through the fascinating topic. Ladies and gentlemen, please join me in extending a warm and professional welcome to Dr. Jisha Anujos. Over to you, ma'am.
Thank you, Alex. So, hope my voice is audible to you.
Yes, ma'am, you're audible.
Okay. So, as I know, you have already had 2 sessions on deep learning, and you are pretty much knowledge with all the deep learning techniques. And I think ma'am has already shared the classification part, object detection, what it actually means by in the theoretical part, and the GAN, everything. So might be some of the topics may be and overlapping to that session, but as tomorrow's session like that, we'll be doing a collab notebook today also with the deep learning techniques. And I tried to include an object detection hands-on also with this, if time permits, because in the introduction part, I'll be dealing with the classification, but I think ma'am have already given a hands-on on classification. So I will just rush through that, and then we can move on to an object detection hands-on, where we can see how a YOLO data set is being created and how it is being trained. So I will be sharing my collab link with you in the chat. And I will be also sharing a database. I'm not sure whether I can share it here. Sir, I cannot send a message here. It is showing you can't send message because you are not a member of the chat.
Okay, I will correct. Try now.
No, still the same message. Should I leave and rejoin?
You may do like that.
Okay. Hmm. Still, I'm not able to.
Joined through Microsoft account or some other?
Through Microsoft itself.
Is it possible now?
No.
Can you present the screen?
Now I am able to access. Okay. So I will share the link in the chat. So everyone, please access this Colab notebook and save a copy in your drive.
Can you share this screen?
Yeah, now I was able to give the chat. No? You can see. So everyone is able to access it. PALAI, right?
Yes, ma'am.
Okay. So actually, I am using a database, but I'm not able to share that here. So anyway, I will show. If not possible to load that, I will like share, like run from my side and show. So you already know what.
I will share the database in the WhatsApp group.
Okay, so if everyone is able to access that from the WhatsApp, then that is also fine. Okay, so meantime,
Yes,
we can
ma'am, we
start.
will take.
Okay, okay, sure. Okay, so we can give a small like introduction on what deep learning is. So deep learning, in a single line, we can say it is a subset of machine learning, which uses neural networks. And why it is termed as deep learning technique? Because it is using a deep architecture where we have a number of layers for the feature extraction as well as for the class determination. Like in terms of classification, we can say we have a classifier stage at the end, along with the feature extractor, which is actually formed by a group of or a number of layers, which together forms a deep learning model. So a neural network, as we all know, is basic neural network is having an input layer, a hidden layer, and an output layer. So what a deep learning network will be having is they will be having more number of hidden layers. Many number of hidden layers will be present in between an input layer and an output layer. And all these neurons will be interconnected by some weight values. So during the process, what happens is these weights are getting adjusted or adapted so that the final output error is minimized. So this is what a neural network does. And if we have a number of neural networks in between, like a number of layers in the network, we call it as a deep neural network architecture. Okay. And with the images, since we are dealing with images, the most basic deep learning technique that we come across in images is convolutional neural networks or CNNs, where they have the ability to learn the features themselves by passing the image into the different layers and then followed by a classification stage. So what a convolution neural network mainly consists of? It is having having convolution layers. I know ma'am has already explained what convolution is. So I just go through what a small example. Like if we have a convolution layer that will be having certain filters, where the filters will be applied on the image. So we'll be passing the filter over the image in section by section, and then we'll be extracting those features. So let us consider if I have a filter which is detecting some lines. That is how my filter is designed. So by passing the filter through the given image, all the lines will be detected and line features will be extracted in the output. So in a convolution layer, we may not be using a single filter, we'll be using multiple filters. So one may be to extract some of a particular type of lines, and some may be some oriented lines, some may be horizontal, and some may be vertical lines. So based on that, we can give in many different types of filters in the convolution layer, and all these filters will be convolved with the image to generate, we call a feature map. So from a convolution layer, if we have like 10 filters in the first convolution layer, that means from the input image, we will be generating 10 feature maps. Then what we will doing is we pass this 10 feature maps into the next convolution layer. where the next convolution layer will be having another set of filters. So what happened? Each of these 10 images will be passed to each and every filters in the second convolution layer. So what do you think? If the second convolution layer is having again 10 filters, that means 100 feature maps will be generated after passing through the second convolution layer. So this is how convolution layer operation is done. So the advantage is we are giving different features or different filters in each layers so that all those features will be extracted in one layer or the other layer. So thus we will be getting a set of feature maps by passing the images into the convolution layers. And and we know another main layer in the convolutional neural network is the pooling layer. So what is the importance of pooling layer? As we have explained yesterday, if we just give the image as such, the vectorization, we know for a classifier to learn, the data should be in 1D format. So if we just vectorize this 100 feature maps, what will be the size? And every image is of about 128 by 128 size, then the vector size will be very huge, and that increases the complexity. And also the second point, that is, many of these pixel data will be redundant. It does not carry any information. So we need to focus on to more informative pixel values. There comes the importance of pooling layers. So mostly what we do is we will be doing pooling layer operation after convolution layer operation. So mainly there are two types of pooling, max pooling and average pooling. Here I have given a max pooling operation. What max pooling operation does is, you are able to view my screen, right?
Yes, ma'am.
It is running, that's why. Okay. So in max pooling, the pooling filter I am using is of 2 by 2. So what pooling operation does is, in this 2 by 2 cells, you will be taking only the maximum intensity value. So 6 will be saved and all the others will be eliminated. The next 2 by 2, the maximum 9 intensity pixel is saved and others are eliminated. So what this actually works is based on human perception. That is, we humans will not be looking into all the features to identify a particular object, right? If you are seeing a cat or a dog, we'll be looking into some of the features and we can decide, okay, this is a cat. So the same concept is being used here without giving the entire pixel intensities, so all pixel intensities. The maximum intensity can help the model in learning the more accurate features for a particular classification problem. So this is what pooling layers does. It not only reduces the size of the feature map, but it also point out to the most important or most prominent features in the given feature map. So after max pooling, we will be having another convolution layers, another max pooling layer. So we have a number of layers in between. And finally, we know to give into a classifier model, we need to vectorize it. So we will be flattening the entire feature maps and then giving into the final classification stage. Classification stage here is formed by fully connected layers. So that is a fully connected neural network where all the neurons are interconnected to each and every other neurons in the next layer. So the final learning process, the classifier learning process, is in the final layers, that is formed by the fully connected layers. And in between, we'll be adding dropout layers. So I will explain why there is a need for a dropout layer. So it is not necessary, mandatory that you should always give a dropout layer. That depends on your use case and your model accuracy. Sometimes you will be training a model with your training data set and you found that your model is giving 97% accuracy. So the model is good, right? But what happens when you give a test image to the model? It show very poor result of around 50%. We call that condition as overfitting. So what overfitting means? The model have trained well on the training data set and has that is not a generalized model. When a new data came, which is which is somewhat different from the training data set. The model failed to understand what the content is and failed to give a good prediction. So that case is called an overfitting case. To reduce this overfitting, we are giving dropout layers. So these dropout layers, even though we are giving that in the model, that will be used only during the training process. So what dropout layers does is, as I mentioned, in the fully connected layers, we have neurons, and each and every neuron is connected to each and every neuron in the next layer. But by adding dropout layers, this model will randomly remove some of these collections between the neurons, thereby making the model somewhat okay. You don't have to learn everything like this. You study less from this data set. So that by dropping some of these layers, the model may not get very high knowledge about the given training data set, but it failed to learn something. But by that, we can reduce the overfitting problem. So that is the need for a dropout layer. So these are the main layers that is coming in a convolutional neural network. And there are many pre-trained models. Without starting from a scratch, it is always better to try first with a pre-trained model. And these are the popular pre-trained models: AlexNet, VGGNet, ResNet, InceptionNet, and there are many others. So we will be doing today's workshop with the VGGNet model, one of them. I hope everyone is able to get the database dataset.
Give the permission for that.
Oh, okay. Oh, I need to. Just a minute. Now, can you look whether you are getting the access?
All of you try now. Now it's accessible.
Once you are able to access and download the database, please upload that into the Colab. Just drag and drop. Can we move forward with the Colab? Everyone
Yes,
is able
ma'am.
to access.
Ma'am, if it is possible, can you please share your screen? I think you have ended your screen share. Yeah.
So I hope everyone have uploaded your data set into the Colab session. And your collab is also connected with the GPU. Okay. So once I'm starting the code explanation. So once you have uploaded your data set, the first step is it is in a zip format. So you need to unzip it. Okay. Okay. So you can see in the dataset folder, we are considering a 4-class classification problem where the images are of forest, mountain, sea, and street. Okay. So this is a publicly available data set that I have access just for this session. There are more number of classes in that, but I limited that to these 4 classes. So we'll be providing the data directory and the class names, street, forest, mountain, and sea. And the next step that we follow is to load the data into the collab session. So the same thing that we will be passing on to the, sorry. Oh, So you understood what mistake I made, right? I didn't give the correct name of data directory. It was dataset, but I gave dataset classification. So that was the error that I made. So I changed the data directory and loaded all the images and checked whether the images is having an extension of JPG, PNG, or JPEG. And again, I resized every images to a size of 128 by 128 so that all the images are of same size. So once the loading is done, we can see the count. The total 2000 images are there in the data set, and class labels are given as 0, 1, 2, and 3, 4 classes, and with each class having around 500 images. So this is the data set that we are currently using, classification itself. Then we can visualize. Sorry for that. So we can see some of the images that we are using in the database. The next step is we are encoding the labels by using a one-hot encoding. So one-hot encoding is like a binary conversion. So we have an example here. We have a cat class. We'll be like giving one, like a bit one for one of the bit, since we are a 3-class categorization problem we are considering, we have a 3-bit value, and one of them is made as 1 representing a particular class. So in cat class it is 1 0 0. For dog it will be represented by 0 1 0, and bird it is 0 0 1. So this is one hot encoding. So one hot encoding we are using that one hot encoding for making the neural network learn better. Okay, so because it is much more better if the labels are given in an encoded format than giving in an integer format. I will save the changes that I have made. Yeah. Just a second. Okay, so we have converted every labels into a 4-bit case, and this is one example, like 1000. That is the label that we have created for one of the class. So once we have generated the label, the next is we need to split the data set into training and test set. Here also I have given a test size of 0.2. That means 20% is used for the test case and 80% for the training set. So you'll be splitting it into X-train and X-test along with the labels. So here I haven't given the encoded labels, but the original labels. I will explain why I have given this. So we can look into the first pre-trained model, that is VGG16 model. This is the architecture. It is having first two convolution layers followed by a max pooling layer, again convolution layer, max pooling. So this is the architecture. And these are the final classification layers, fully connected layers followed by the softmax layer. And like I explained yesterday, we can use this pre-trained models in 2 ways. One is we can use this pre-trained model as a feature extractor, and the second is we can use them as for transfer learning. First, let us explain how it can be used in a feature extraction method. So yesterday in a machine learning session, we have used a hog descriptor, which is actually extracting the features from the images. So instead of using that hog, here what we can do is we can use this pre-trained VGG model for doing the same feature extraction and then give those features into some classifiers and for the prediction. So this is the first thing that we'll be seeing now. We are loading the model from TensorFlow Keras. And you please look here, we are loading the model into a base model variable, and here it is assigned weights as ImageNet. That means we are using the weights, a pre-trained VGG16, which is trained on the famous ImageNet database. So that weights we are using in our case. And the second thing is include top equal to false. That means should we maintain or should we have this final layers, this classification layers or not? The top layers false means we are not using that final fully connected layers and the softmax layers, because we need to train a model based on our data. That's why we are excluding those top layers. Then the next parameter that we'll be passing is the size of the image. Since we have reshaped all the images into 128 by 128 size, I have given this image shape as 120. If you are using, can anyone say why we are excluding the top layers? What happens if we are using these final layers?
Edges will come.
Sorry. So what this VGG16 model, no, as I have mentioned, it is trained on ImageNet dataset, which is having 1,000 classes. So this model is actually trained to classify 1,000 classes. But in our case, our class category is only 4. So this softmax layer is actually trained or is having an output, having neurons to generate 1,000 outputs. But for our case, we require only 4 cases. That's why it is will be always removing these final top layers from our use case if we are using a different number of categories. Okay. So we have excluded the top layers from the pre-trained VGG16 model. And what we'll be doing is, since we need to pass the final max pooling layer into the fully connected layers, we'll be using a flattened layer. That's why we have flattened the output. The output of the base model is taken into a variable X, and we have flattened that and saved in variable X, and that is forming the output of this particular model. So we are actually creating a sub model from the actual VGG model, which ends up at the max pooling layer, and we'll be getting the output from the max pooling layer. So I think till this everyone is clear. Okay. So when you run this, you can see that the model is being downloaded here. So now our model is downloaded, and we have created a sub model based on the given model. Next, what we have to do is the same process. We will be passing each images one by one into the feature extractor and extracting the features. So here the feature extractor is the VGG model. It will take some time. So once we have extracted the features, then we'll be also extracting to evaluate the model. We'll be also extracting the features from the test set also. Hope till this you are able to understand. So let that continue. So what the next step we'll be doing is, this is using pre-trained model as a feature extractor. So we have used the VGG model to extract those features, and then we will be training a model based on those features to get the prediction. So here I have just selected an SVM classifier with the kernel SVM classifier for the process. You can also try other kernels and also linear SVM is also fine. So you can try different SVMs and or any other classifiers, and you can check how the accuracy is. So where does this particular approach is useful is when we have very less number of data. That is the case where we will be using this particular application, like using a pre-trained model as a feature extractor, and then using like a conventional classifiers for the training process. So that is mainly used if we are having a very small number of data and there is no sufficient data for training a model or creating a model from scratch. In that case, we will be going with this approach. So once my features have been extracted, we are training the SVM classifier, and you can see like the test accuracy is 97.5%. So even with a pre-trained model, which does not make it, I'm not sure whether among the 1,000 classes it has learned any of these classes, but still in our application, this is actually giving a good result even without any training. So this is the first approach. If you are trying to use any CNN in your application, you can just try out whether any pre-trained model with a traditional machine learning technique is providing any hope in your process. So the next approach is, as I have mentioned, it is transfer learning. In transfer learning, we are making the weights to be changed. So here also we are loading the model, the same model with the weights of ImageNet database, and the top layers are made to exclude. And we can see the number of layers in the base model. It is 19 layers. Now what is the one that we are going to do is, we can freeze some of the layers. Freezing some of the layers means we are not changing the weights of those layers. That option is for you. Either you can make the entire base model not training any or not changing any weights. So this is what we are doing. So if we are running this particular line, we are making the entire layers non-trainable. The trainability is made false in this case. We are freezing all the layers of the base model. Only thing that we will be training is the final fully connected layer.
50% data gali super. நான் வந்து ஷேர் பண்றேன்.
Okay, so one method is you can freeze the base model and only train the last fully connected layers and the softmax layer part. Or the second type is you can freeze some of the layers of the base model and unfreeze some of the layers. So you can see we have a total of 19 layers in the base model. Here I have made the first 10 layers as non-trainable, that is freeze. Its weights will not be adjusted based on my data. And the last 9 layers, we will be making the layers as trainable. So based on our data, that weights of the model will be changed. So you can try with the first one and how you can check. And you can, if that is not working fine or not giving any improvement, you can try with this approach. And this number of layers that is to be trained, made trainable or non-trainable, that you can try as a trial and error method. Okay. So here we will be doing the trainable format, that this one. And once we have set which are the layers to be trained and which is not to be trained, then we'll be adding the flattened layer and the dense layer. So you can add any number of dense layers according to your application. Let's try with 128 dense layers followed by the final classification layer. Here we are using 4 because in our case, our categories are 4 and the activation is softmax layer. So this is our final classifier layer. And these are the neural network layers, hidden layers of the neural network, where the training process is, like learning process is taking place. So based on this, we are creating a model. So you look here, in the previous case, our model was like this. model input was the base model input and output was the final base model output X. In this case, we are also creating a model with input as the base model input and output as the final dense layer output X. Okay, so this is how we have created a fully trainable, a fine-tunable VGG16 model. And the next step is we need to adjust, we need to provide optimizers and the parameter on which it is to be evaluated and what are the loss types to be evaluated. So those parameters we need to give. So optimizers, we know that is used to adjust the weights. So we are adjusting for all learning process, we are adjusting the weights. So how accurately these weights has to be adjusted so that the error get minimized. So for that, we are using optimizers where we provide a very important hyperparameter, that is learning rate. So usually, we don't give a large learning rate. What happens to when we give a large learning rate is because is that it will just the weights will be adjusted. It will be changed very hugely that it never reaches into an optimal minimum point. Usually, we will be setting the learning rate as very small value. So I will say what it is. Like we have an optimization problem, like we consider this curve. So this is the optimal value. Okay. So and the weights are adjusted like new weight will be equal to new weight is equal to old weight minus learning rate into the gradient of loss. Okay. So we have the first weight here. Let us assume we are having the weight, the initial weight was set here. The next weight will be reduced based on the learning rate value. So if you're giving a large learning rate, what happens is the weight will suddenly reduce to a larger value, again jump into a larger value, then again it may jump into some random value, again it may jump into some random. It may be very difficult to reach this minimum point. So what we do is we always set this learning rate as very small so that this jump is lesser. So it will be jumping slowly and ultimately reaching into the minimal point. So this adjustment of weights so that the loss is minimized is done by optimizers. I hope this is clear. So here there are many other optimizers, ADAM, SGD, ADA-grade, ADA-delta. So these are adaptive optimizers. That is, in ADAM and SGD, we need to set the learning rate ourselves. But here, these two optimizers will adjust the learning rate based on the previous gradients. So if the error is reducing, then they will start, or error is increasing, they will automatically adaptively reduce or increase the learning rates. So that is these ADA-grad and ADA-delta optimizers doing, while these two we will be providing the learning rate. So here we are using ADAM optimizer with a learning rate of 0.001 and cross entropy, categorical cross entropy loss function is used here. Since we are using encoded labels, we will be going with the categorical cross entropy. If you are using the integers as such, like 0, 1, 2, 3, then we will be going with sparse categorical cross entropy. So why we need, in which case we need to use sparse and which case you need to use the categorical is that if we have like thousands of classes, what happened if we vectorize it, we'll be having a 1000-dimension label for each class. So that is again increasing the complexity and more memory will be required. So in that case, we can use the integer as such, and then we will be using the losses sparse categorical cross entropy. And if we have less number of classes, it is better to use this encoded version. So then we can use categorical cross entropy. So once we have set the optimizers, we'll be compiling. So this is how our model is. This is the input layer. we can use the summary function to view this. The convolution layers. So we can see these are the layers that we have added: flattened layer, dense layer, and the final classification dense layer. This is just to, if you need to save the model in a PNG format, you can run this. Okay, that is fine. Now, previously we were splitting that based on the integer value, but here, since we are using categorical cross entropy, we will be using the encoded label functions. We'll be splitting it and starting the model training. Here, we are just giving 20 epochs and validation split. Validation split is, we are not using this X test here for the validation process. Instead, we will be splitting this train set automatically into validation set in a ratio of like 20% belonging to validation and 80% of them will be used in the training. So you can see this is how the accuracy is going. This is the training accuracy and this is the validation accuracy. So once this training is being done, the best thing to evaluate is to look into some visualization of how the accuracies are, whether it is overfitted or not. So that we can understand by visualizing the training validation accuracy plot or training accuracy loss plot. So for that, we are using this matplotlib function, where we'll be getting both the training accuracy and validation accuracy plot. So this is how my training and validation accuracy. So almost the validation and training accuracies are almost going in line. Okay? And maximum it reached about 70%. So based on this, you can understand if in case you are training it for 50 epochs and you can see like after 30 epochs, okay, you can decide how many epochs may be needed. After 30 epochs, if there is huge variation between the validation and training, like training is very high and validation is very small, that means the model is going into overfitting case. So there is no need for further checking. You can stop, you can reduce the data, like reduce the number of epochs to 30, or you can change the hyperparameters of the model for further fine tuning the accuracy. Yeah. So then again, on the test set, we are doing the prediction to create the classification report. I have explained the classification report in the previous session. So you can see, since we are using encoded labels, how the actual prediction of the model looks like. So this is the prediction in encoded format. This is how we are actually getting from the model. So from this, what we'll be doing is we will be looking for the maximum value vector. So this third one is the maximum value. So we'll be predicting the model, like predicting as class label 2. Class label 2 means we have started from 0. So 0, 1, 2, third class. Whichever is the third class that we have assigned, that third class is being predicted for the given X test input. So this is how we are getting in the encoded format the prediction. And then we are doing a checking for the maximum value vector in that. And that is being taken as, that index will be taken as the final true value. Okay. Then we are plotting the classification report similar to yesterday. So here we don't get much accuracy. Previously that was 97. So there is some problem in our approach. Either maybe the layers added in the final, like in the dense layer, that may not be sufficient, or it may be the problem with the learning rate. It may be again problem with the optimizer. So based on that, I request you should not change many parameters simultaneously. First, you may try to change the model structure, then check with the same parameters how it is working. If still it is not working, then you can try to change some other parameters like that. So all at a time, you should change only one parameter or one condition. So this is how we can use a pre-trained model for with as like as a feature extractor and as for a transfer learning operation. Another thing that is we can create a CNN model from scratch. I think the previous session you have already seen this, where we will be creating a sequential model by adding the different convolution layers, whatever filter size you can add, number of filters you can add, and then followed by max pooling layers. So this is up to you. You can add different convolution layers, max pooling layers with different number of filters, different filter sizes. Everything is possible, and that is up to you. So you can create such a model from scratch by using the functions from Keras TensorFlow. And then again, after giving all the convolution max pooling layers, then we need to flatten it and give the dense layers, followed by the final soft max layer. So this is the same thing. I think you can run this and do the same process will be repeated. Only the model creation is different here. Here we will be creating our own model. We have the flexibility to add the layers here. How many layers, how many filters, what should be the filter size, everything you can decide. So I'm skipping this running operations. Okay. So you have seen how a classification model can be generated using pre-trained model, both pre-trained model and from scratch, and you have seen an example. So next we can move on to another most important topic, that is object detection. And the most common model that is used in object detection is YOLO. And YOLO have actually releasing a number of versions. Currently, it is YOLO V11. So where it is having a numerous, not just object detection, they have numerous applications there. Object detection, classification, segmentation, oriented object detection, everything. So there are many features that's being added in YOLO V11. Okay, if you are interested in, or if you are doing something related to object detection, please go and look into YOLO V11. So that is a recent one, and it is very advanced. So it is like 2 months back, I heard about V10, but recently V11 has also been declared. Okay, so everything of YOLO is being developed by Ultralytics. So what you need to do is you need to install. So till now we didn't do any installation in Colab because Colab is already supported with in all those packages that we have been using. But this we need to install. So if you are running this code in your local system, you may need to install many other packages. So since we are using in Colab, till now we didn't see any installation parts. So this we will be installing Ultralytics. The next thing is, okay, so I was just checking whether GPU is supported or not. Okay, so CUDA service is there. So before going into how you can train this, let us see how a database is created. So I know most of us will be doing some object detection on your custom data. So for data creation, what we follow is we'll be using a tool called Label IMG. Sorry. Okay, so I have installed this Label IMG in my system. So if you are thinking of training a YOLO model on a custom model, you can install this Label IMG tool in your system. So this is the screen of Label IMG. You are able to see my screen, right? The Label IMG screen.
Yes, ma'am. Yes.
So you can open the image on which you have to detect, or you have to mark the object. So I will be taking one set of images. So this is the image that I am taking. This is the image. So I am trying to create a model, a YOLO model, which will be detecting some of these objects. So here we have an option to save the labels in different formats. Since we are trying to train a YOLO model, I am selecting the format as YOLO. You can also select ML or Pascal VOC format. That depends on your applications. So here we have selected YOLO format. Then the next thing is we need to create the bounding boxes. So I have selected rectangular box, create rectangular box option. Then we are providing an option to select the region to mark the object. So we can select the region where the object is and you can give the label. So here I will be giving the label as bottle. Okay, so this label is being saved here and saved. So saved, I will show one of the saved label output. So this is how it will be saved in a TXT format. 0 represents the label, that is, it is assigning bottle class as label 0. And these are the coordinates of the bounding box. So this is how a label file will be saved in the label folder. And if we have more than one, objects, that also is possible too. We can easily save those or mark those also in the same image. Okay, so here you can look, we have a bottle, we have a can, and we have another object. So we will be selecting this rectangular creation. Okay, bottle is there. Then again, click on rectangular box tool, mark this, and you can give it as a can. So multiple objects can also be labeled in the same image. And if you save this is 57. So if you go and see 57, there are two objects, one belonging to 0 class, one belonging to 1 class, and this is the bounding box of each of them. So this is how we will be getting the labels. I hope this is clear for you. Okay, this is the main tool that we will be using for labeling images for creating an object detection model. So please note this particular tool name, label ing. Once you have done the labeling of entire image data set that you have, and you have created the labels in the folder, the next thing that you should follow in training a YOLO model is it have a specific folder structure to be followed for training. So I will show that. So this is the data set we'll be using. You can see that is COCO 8 data set. You should have two folders, one as images folder and one as labels folder. So this is a predefined folder structure that is to be followed in YOLO. Images folder and labels folder, and inside images you will be having two folders, train folder and validation folder, where train folder will be holding the training images and validation folder holding the validation images. Similarly, labels folder will be having two folders, train folder holding the text txt file of those 4 training images, and validation txt file of validation images. So this is the folder structure that is to be followed in YOLO. So you need to understand this. You need to follow this particular folder structure if you are trying to train a YOLO on your custom model. Okay, so this, once you have set this folder structure, the next thing that you need to do is we will be using a configuration file for training the YOLO model. So that we call it as a YAML file. I will show that. You need not to be worried, like this is simple only. That will be within the Ultralytics folder. Okay, I will just show that. Okay, so here we have a number of configuration files. Configuration files are actually holding the path to your training data set. or to your folder structure. So let us open one of the YAML file. You can see here we are actually giving the path. Our data set, like our folder structure is data sets Coco 8, you remember, right? And then inside that images train, that is our training data set. Similarly, we are providing the validation images val folder structure. If we have any test image, then that path also we can provide here. So this is what a YAML file will be holding, and it also contains the labels. That is, if it's 0, in our case it was bottle, so you need to replace this person by bottle. In 1, our case it was can, so you need to replace that by can. So how many classes you have, that many classes you can add here, and you can give the labels here. So this YAML file is also need to be edited. So 2 things that you need to like understand while trying to train a YOLA model custom data is, one is the data folder, like folder structure, and the second is you need to edit the YAML file with the corresponding parts of the training and validation data set and the classes. Once this much is done, you are ready to train the model. Okay, so in the Colab, I have already written, I will be using YOLO 8, V8 model and Nano model. And look, I have used a Coco 8 YAML file. Okay. Coco 8 YAML file, and number of epochs I have set to 2. Image size I have just given as 128. And devices, if you are using any GPU, you can give it as 0. Or if you are running in CPU, you can give it as CPU. So once we run this, the model training will start working. So the path of the data will be taken from this YAML file. So here I am just using the inbuilt data, right, from the Ultralytics, no other data set. Look, when I started running this particular data set folder is being created here in Coco 8. Okay, so the training has completed. We have given 2 epochs. So this is how we can see. In first epoch, we are getting a precision, recall, MAP values. The second epoch, it is completed. Okay. So it also show how many hours is taken to complete the 2 epochs. And the thing is, the best model and the last model will be saved in a particular folder. So you don't, like in the previous case, we were actually saving the model, right, in a pickle format. So here, the best model and the last model will be saved in runs folder, in the detect folder, train. This wait folder holds the final trained model. The best model and last model specify, like if I am running my YOLO for 100 epochs, the 100th epoch trained model may not be the best model. In between, maybe I might have get a very good model. So that weight is saved as best.pt. But if you want the last like 100 epoch trained model, then you can use the last.pt model. So these 2 weights will be saved in this folder. You can use that for your application, like for the prediction operation. And here also we can see the confusion metrics is being plotted here, precision, recall, everything with respect to each images, each object, how much instances have been correctly classified, how much is correctly detected. So that is being displayed in this. So by this we can understand how much or like what is the accuracy of our training process. Okay, so this is how we will be training. So this training process is very simple. The thing that you have to understand is most of them goes wrong in that data creation and in the folder structure. So once that is being set, then you just need to run the model by using this function, providing the correct data like parameters. you can easily run the YOLO model. So once the model is like created, the next thing that you can do is you can predict on this. So we have the best model in this runs folder, right? So I have given that path for using the best model, and I am passing one of the image for the prediction. You can see the prediction output. So this is the prediction output that we are getting. 50%, it is confident that this particular object is a best with 50% confidence. This person with 70%, this with 37. Here, this person is also being detected with 43% like confidence. So this is how we will be predicting or doing a prediction using our trained YOLO model on a given data set, a given image. Hope till this everyone is following. I just didn't stop in between because it will take some time, right? So, is there any question till now, or else I have created actually a UI to show you, a very simple UI creation also. Once this much is clear, we can move on to the UI. Is there any question? Anything related to object detection, because classification everyone might have known.
Madam, I'm Shweta, and my question is, how can we have a good hyperparameters? How can we adjust that?
Hyperparameters, like it is like a trial and error method we can try. That's what we can follow, because the learning rate, these are the hyperparameters, right? Learning rate and everything. You just try with one, or else the thing is you can go with the adaptive learning rate optimizers.
Okay. So for a best optimized model, what can be done?
For getting the most optimized model.
Yes, ma'am.
Yeah, the approach that I did was like I didn't actually created any model from scratch. I also used the pre-trained model. So the transfer learning approach I have been trying. So as I mentioned, initially I made some of the layers as trainable with my data set and fixed one of the optimizer with a given learning rate. So that experiment I did for different learning rates and different, okay, without changing the model structure, I did and changes in the optimization part, in the learning rate, such changes I tried initially. So after many trial and error, still if I didn't find any improvement, then only then I will be moving on to the model side and change the, or maybe increasing the, one thing we can check is like if a model, if you are adding like 5 layers into the pre-trained model and you found it as overfitting, that may be a problem with the number of layers. So you can reduce the number of layers, because that much heavy model may not be required for your application, that much deep model. Why I say this, because is my classification, what I did was mainly on the classification based on structures. So structural features were more important in my classification problem. But my colleague was working with medical images where minute features were required. So for that person, the less deeper models like VGG were not providing sufficient accuracies, because VGG is a not that much big model, right? It is having only 16 layers. So that model was not working fine for that person, because they need very fine, very minute details. But for my case, since mainly on the structural details, my classification was depending. For me, those VGG like less models were working fine. So based on your application, you can decide whether to use deeper models like EfficientNet or BreastNet 50 is better for you, or a smaller model is required for you. So that is one thing based on the model architecture. The next is the same thing, like you can give different trial and error methods and optimize this learning rate and the number of layers.
Okay. Thank you, ma'am. Thank you so much.
Okay, then if there is no more questions on this part, I will show a small UI. It's very simple UI that I have created using Streamlit function, the Streamlit library. I have previously downloaded the same YOLO model that we have trained. So I am loading that model from my local path here. And then using the Streamlit, I have given a title as object detection model. And we have provided an option in the Streamlit to upload the file. So upload an image, and we'll be uploading only those images with these type of extensions. And once the upload is done, we'll be passing that image into a model, and the model results will be displayed. So this is a very simple UI, and I have created that using Streamlit. So let me show how this UI is working. So this is the UI. I hope you are able to see my screen. This is the UI that I have created for object detection. So here we have an option to drop our data. I will just give the cat image that we have used yesterday. So then on clicking the predict option, our YOLO model will be running, and that is been detecting the cat with 72% confidence. So this is a very simple UI. It is not that difficult to create a Streamlit UI. So once without running, we can, if you need to showcase your work, it is better to create a UI rather than just showing like a code running, right? So that's why it is always good to show, because sometimes, as previously what we felt is that some error may be happening by mistake. If we are not saved or by accidentally we have inserted something, our code may change. So that will not happen if once we are running a UI. So this is more user friendly and more, I think it is more easier like to understand what we have done. So this is actually running in my local system. This is a desktop application. If we need to provide this to other worldwide applications, users, then we need to host our UI in some like cloud platforms. There are many options for us to load this UI in cloud, like you can use Streamlit IO. Streamlit itself is providing an opportunity to share that UI for the public use, that is Streamlit IO, and even Heroku is there. Then Azure we can use, AWS. All these are providing different services where we can host our UI. So I will also share one of the UI that is not related to object detection, but I have done a hackathon recently. So our team have developed a UI, and that is being hosted. That is also a Streamlit app UI that is being hosted in Streamlit IO. So this is the UI. So if anyone with this particular link is able to access it. So this is not a local, like a desktop UI. This is a web UI. You can access it from anywhere. Okay, one method, like you can upload your work and showcase to some other users too. Okay, this is actually, I will just give a small idea on what we did in this. Okay, here our task was to generate different types of like post contents based on the platforms like LinkedIn, Twitter, or Instagram. And we can also provide different tones, like whether it should be a casual, professional, or humorous tone that content should be, and about a particular content. So what this particular UI does is the user query will be going into a news API where the recent news related to given user query will be extracted, will be taken. And from that content, based on the tone and based on the platform, the large language models will be generating these particular formats. So the user can select a text, that is, if we need text content based on this tone and platform on this particular topic, that LLM will be creating that. And we have also used image generation model, diffusion model for image generation based on these. Video generation. So video generation, because that was mainly paid API. So we just concatenated. So our idea was not to use any paid API. So we just concatenated the images that was being obtained, that has been created using LLM based on these tone and platform, and that was combined together to form a video, and also meme. So this was the use case that were provided to us. I will just run and show you one. Climate change, humorous, Twitter or something. So this is actually a Streamlit UI. You just think this is, I think this is not that bad, right? We can like make a wow feeling to the viewers, even with very little small. I don't have much idea on the UI creation in other domains, but we are just using Python here to generate these particular UIs. So this is how I'm getting global temperature rising. Okay. So this was one of the UI that we were developing in that hackathon. Okay. So I think I have covered everything that I was meant to tell in this session. You can look into every details regarding YOLO. You can go and search into Ultralytics. Everything is there. And make sure if you're trying to use any object detection model, you go and look into, not object detection, because YOLO V11 is having many other functionalities, even segmentation, classification, everything. So you look into Ultralytics. And if you are interested in creating an UI, do visit Streamlit documentation. Everything is there with examples, so it is not that difficult for anyone to create the UI. So is there any queries?
Yes, if there are any participants who would like to ask any questions to Dr. Jishan, this is your opportunity. You can freely unmute your mic, or you can chat your question or queries in the chat section of the Teams app. Thank you.
Training YOLO in the mobile, I'm not sure whether it supports that much space in the mobile. But if you have, even if your system is not having any GPU, that is fine. You can use a CPU for training. Only thing is, it will take a little longer. You can train a YOLO model in your system without GPU. That is fine. Train the YOLO model in mobile. That is possible. Yeah, that you can use. Because a trained model, that we will be using the GPU only for the training process, not for the prediction process. The trained model we can run in a mobile. That is fine.
Are there any more questions? If you would like to ask them, please make sure to unmute yourself and proceed to ask your questions or queries.
Plant leaf classification. Like I said, no. If you are more into like leaves, maybe having different structures, no. So structural details may be fine with less deeper models like VGG 16, VGG 19, and LetsNet. If you are dealing with leaves which is more similar in structures, then you may need to use more deeper models. So if there is sufficient differences between the shapes of the plant leaves, then you can go with these smaller models.
Alex?
Okay, sir. So, yeah, I hope everyone has asked their questions and queries. Now, I would like to take this opportunity to thank Dr. Jisha for sharing her knowledge with us today. Your session was truly insightful and inspiring, ma'am. You gave us a clear understanding of what deep learning is, how it differs from machine learning, and also provided an in-depth explanation of CNNs and their functionalities. Your hands-on session on how to use VGG16 model, the usage of various optimizers, and how to train a YOLO model was highly engaging and immensely helpful in enabling all the participants to grasp the fundamentals of the topics discussed. Once again, I would like to thank you, ma'am, for sharing your expertise and knowledge with us today. Now, I would like to invite Ms. Needu Tom, the session chair, to present the virtual memento to our esteemed resource person, Dr. Jisha, as a token of her appreciation.
Very good evening, all. Thank you, Dr. Jisha ma'am. As a token of our appreciation, we would like to present you with a virtual memento. This is a small way to say thank you for your valuable time and effort on these 2 days. Thank you, ma'am.
Thank you.
Okay, so before wrapping up, I would like to kindly remind all the participants that your feedback is very important to us. We will share a feedback form in the chat as well as in the WhatsApp groups. You will be given a participation ID along with it in the WhatsApp group as well. So please take a few moments to fill in the Google form out with the given corresponding participation ID that you have because it is essential to mark your attendance. Okay, with this, we conclude today's session. I extend my heartfelt gratitude to our esteemed speaker, Dr. Jisha Anujos, for delivering such an enlightening and thought-provoking session today as well as yesterday. Your session truly helped us widen our knowledge about AI and its related topics such as CNN, how it works, and about various models such as YOLO, etc. Once again, I would like to thank you, ma'am, for enlightening us. And now I would like to express sincere appreciation to our coordinator for their dedicated efforts in organizing this event and ensuring its seamless execution. Also, a special note of thanks to our faculty chair, Ms. Needu Tom, for her invaluable guidance and support throughout. Lastly, I thank all the participants for their enthusiastic engagement and active involvement, which greatly contributed to the success of this session. Once again, thank you all for being part of this enriching experience. I look forward to your presence in tomorrow's session as well. Wishing you all a pleasant evening and good night. Thank you.